Today we're going to learn about how to reduce and save energy every day. Hi, I'm Shauna with the Governor's Office of Energy Development. I'm here to talk to you about energy efficiency. So what is energy efficiency? Unlike most energy resources, which are mined or drilled or captured from wind or solar heat, energy efficiency means using less energy to accomplish the same goal. For example, you can use insulation to keep heat from escaping your home when it's cold outside. Insulation's a lot like wearing a coat in winter. It protects you, so you don't need to run around or do jumping jacks to stay warm. Insulation does the same thing. If you have an insulated home, hot air doesn't escape to the cold weather outside, which means you don't need as much energy to heat the home. Using less energy means more savings. Energy efficiency also helps the environment because we need less energy. And using less energy resources means less emissions. And as you know, reducing our emissions at homes means better air quality for everyone. In Utah, we're constantly looking for ways to implement energy efficiency and have gotten better and better every year. A national organization called ACEEE ranks states based on their energy efficiency programs, and we just earned 17th place, up from 23rd just 2 years ago. In fact, Utah unveiled its first net zero community, which used heavily insulated homes to prevent leaks in the winter and in the summer. Because these homes are built so airtight, the temperature remains practically the same regardless of what the weather's like outside. Now let's try our own insulation experiment. For this activity, you'll need a student activity sheet, a cold soft drink, some cool thermometers, and various materials to use for insulation. I've got newspaper, a towel, bubble wrap, and cotton balls. You'll also need a stopwatch. Your goal is to construct the perfect koozie, a sleeve that's designed to thermally insulate a beverage container so your drink stays cold. We'll try to stop heat flow by conduction, convection, and radiation. So first let's look at heat flow. I'm going to point the thermometer at my hand. Let's check out the temperature. 86 degrees. Now, I'm going to point the thermometer at the can and record the temperature. 65 degrees. So what do you think will happen if I hold this can in my hand for 30 seconds? Write it down in your student activity sheet before I test it out and see. Now I'm going to hold the can for 30 seconds. So what's the temperature of my hand? It's 77 degrees. In which way did the heat flow? From my hand to the can or from the can to my hand? What form of heat transfer was that? Was it conduction, convection, radiation? Now we're going to run the same experiment, but using insulation to demonstrate energy efficiency. Using your materials in front of you, come up with your own insulation design and write your idea down and staple it to your paper. I'm going to use a towel and bubble wrap as my insulation design. And now I'm insulating my can using the design. This time, we'll run the same experiment using the insulated can. I'm recording the temperature of my hand, 82 degrees, and I'm going to hold the can for 30 seconds. And now I'm re-recording the temperature of my hand, 80 degrees. Check it out, there was only a 2-degree temperature difference, demonstrating that my design effectively insulated the can and my hand from falling in temperature. And just for fun, we're doing the same experiment with our thermal camera, which shows an image of the temperature of different things. You can see that the regular can is really cold by its blue coloring compared to the insulated can, which isn't quite as blue. So here's a few questions to think about. How did your koozie perform compared to others? What are some common factors in those insulated designs that performed well? How could you improve your koozie? What factors limited your design? Thanks for watching. You can find this and more lesson plans on our website at energy.utah.gov.